All right. Well, hello, Sinumerik Nation. How is everybody doing today? It's interesting. Just getting set up here. We're going to be starting here in a minute. Hey, Dan, do me a favor. Unmute yourself. Maybe it's the way we have it set up, but I'm not seeing anybody in the audience, but I'm seeing it from my other screen. Are you seeing that, or does it look good from your side?
I do not see any people yet. There's not a total count yet. Nope.
So when you go to people, it says there's currently no audience in the webinar room. Yet I see a bunch of people saying hello. God, I just love this software.
It's your favorite, right?
It's great. All right, well, I know you guys are there. I can't see you, but you hopefully hear me. I tell you what, if somebody
We got
could
12.
maybe, yep, I see BC says we are here. Okay, good. So we're going to go for it. I think we're all right. I see I see the top count says 12. All right. It's always fun with these live events for sure. Well, thank you everybody for joining for another one of our exciting Sinumerik webinars. Um, let me get the slide deck started here, and we'll dig into it. So today we're going to explore the exciting world of dynamic fixture offsets, and what do we mean by the term dynamic fixture offsets? But before we do that, I do want to get a chance to introduce myself. So for those of you that may not know me, my name is Chris Pollock. I manage the technology application team here at Siemens, and I have the pleasure to manage three top stellar guys, rock stars in my team. So we have Dan Struble. That was the gentleman I was just talking to there briefly. He's a CNC specialist for the team, really focuses heavily on advanced technology, 5-axis, all that good stuff. We've got Adam Caves, which is the newest member of our team. Adams is a system engineer, and he's been heading up all of our service trainings out of Elk Grove Village. We'll talk about the training classes in a bit, but if you come in for one of our service classes, you'll get a chance to meet Adam. And then we have Brian Baumgartner. Brian Baumgartner is also a systems engineer. He's been with me quite some time now. And Brian handles a lot of different tasks for us, but he's definitely one of the ones when nobody else can figure it out, we drag Brian into it, and he can usually get it. All right, so just a little bit of area for information for you guys before we get into the core topic. If you're not familiar with CNC for You, that's our main website or main landing page. That's the URL right at the top of the screen. And one of the things that I'd like to point out on CNC for You is this is where you can get access to all of our training classes. So from the CNC training side, if you go down to that tile, click on the link, you can see both in-person online classes that we host. From there, you can get an overview and you can register for the classes. All of our classes are 100% complimentary. So by all means, if you're looking to expand your knowledge of the Sinumerik product line, please, take advantage of them, come in, work with us, whether it be online or certainly in person. If you don't know it, you definitely want to check out our Mr. CNC YouTube channel. Here, it's all things operation and programming based, but we have a ton of material, a ton of videos to help support you more from kind of the self-paced learning side of the world. So for sure, like and subscribe if you're not already. That's real important for us to keep kind of growing the channel and showing the importance and the adoption by the market space. And one of the programs that I just mentioned, Brian Baumgartner before, manages for us is what we call our Virtual Product Expert Program. And this is a great program. You can get to it still right from CNC for You, or you can use that direct URL you see on the screen. But this program allows us to effectively schedule a one-on-one meeting. So if you have any questions, from the Sinumerik side. It doesn't have to be technical in nature. Maybe you're new to the product or you're interested in learning about the product from a sales side. So certainly both pre and post sales, but you just go online, fill out a quick little questionnaire. Brian will get a hold of you, and then we'll figure out who is the best specialist to work with you. And then usually we'll set up a Teams meeting. They're typically a half hour to an hour long, and we can help kind of navigate you through the massive company that is Siemens, especially from the Sinumerik side. Our content manager is another piece of tool or kit that you can download from our CNC4U website. Contact Manager is just a simple Excel spreadsheet, but it's got links to all of the videos we've produced. It has links to all of our manuals on other tabs. It's really a great resource. So if you don't have it, I would say by all means, get over to CNC4U and download the Content Manager, and then download it periodically because we update it usually about once a quarter. Make sure you sign up for our contact list if you haven't already. This way, when there's new events coming down, you can at least get a notification, so you can sign up for the contact list on CNC4U as well. And there's just a few of our direct links to some of our social media, YouTube, whatnot. But I did want to focus and highlight a parallel or a sister channel we have to the standard Mr. CNC, which is called our Mr. CNC Insights channel. This is our newest channel, and it is specifically focusing on service and commissioning topics. So we found that the main channel, there's so much content there that you can kind of get lost in the weeds as far as you're looking for specific topics. So we're trying to now break out our service and commissioning topics will sit on the Insights channel, and then our operation and programming channel, our programming topics will sit on the standard Mr. CNC channel. So if you haven't been to it, just do a quick Mr. CNC Insights. If you go to our main channel, you'll actually see there'll be right here in the center of the screen, there'll be a direct link to go back and forth between the two channels. So they are interlinked, but you do want to make sure you like and subscribe the Insights as well, because it is a separate channel. Okay, so that was a few things I thought you guys might get some interest out of, but now it's time to drill into the real topic at hand, which is what we refer to as dynamic fixture offsets. And I would say what the industry refers to as dynamic fixture offsets. So what do we mean by that term? What is a dynamic fixture offset? Well, typically this is going to be discussed or talked about once I introduce rotary axes to a machine tool. And the minute I introduce a rotary axis, as I place a part on that rotary and it's not dead center of the part, it's shifted somewhere, or at least my zero is not dead center of the part. As I spin or rotate, as you see in this graphic, this part to different orientation angles, its position will change in space. So what a dynamic fixture offset will attempt to do is effectively track wherever my zero was placed on that part and calculate, as I move it around, this new zero location. So that's what we're going to kind of dig into in a lot more detail over the course of the next 45, 50 minutes thereabouts. So when do I use them? When do I not use them? It's always, in my mind, whenever I'm digging into a new topic, it's always my first question, right? Do I do this all the time? Should I always use dynamic fixture offsets? So I wanted to set up a few scenarios where you'll definitely get a benefit or an advantage from it, but where probably it's not going to do a whole lot for you. And I would say these first two do not require dynamic fixture offsets. So our setup on the left is a very traditional fourth axis part. And in this case, I'm working from the center line of my cylinder, and that's going to be my zero location. So zero specifically in this machine, since my rotary is rotating about the x-axis, it's an A rotary. My zero for Z and my zero for Y would be dead center of the part. And here, there's no real huge benefit for using dynamic fixture offsets because I'm rotating around that same center line. Could you use it if you wanted to maybe shift the zero up to one of those flat planes? Absolutely, there could be some benefit, but generally it's not a huge scenario. And the other area where a lot of people immediately think, boy, I should be using these diameter fixture offsets would be like a tombstone, right? Where I have multiple clampings of multiple parts. Well, the one you see there on the right, that's a little bottle opener demo that I do. But in that case, the part itself, I'm only ever machining on one face of the part, right? So I'm effectively coming top down. I'm not doing any work on any, compounded angles. So once the rotary axis has spun into position, setting what we would call our surface normal. So I'm either like A0, A90, A180, there's no extra rotary motion. So in a case like that, I can handle the orientation of the part right at the fixture offset level. And I don't need to worry about where the center line of the part is because I'm not moving it around. So just because I'm on a tombstone, don't think you have to go dynamic fixture offset. Probably not a huge benefit there. But when I get to parts that I'm now approaching from different angles and different orientations, this is really where we can start to see the benefits of a dynamic fixture offset. So in this little example, this is our setup where we were machining some of the golf putters. If you stop by the booth at IMTS, you might have had a chance to see us kind of promoting and using them. So in our scenario, we actually machined them all on a 4th axis tombstone, but we couldn't machine the whole putter coming at it from the same angle like I can do, say, in the bottle opener. So we were flipping it maybe 90 to get to the back. We were flipping it at a small angle to machine the face of the putter because the face of those putters are raked at like a 3-degree angle or so. So once you start moving this around, this is where the fixture offsets become very handy. Because if I don't use them, then everything has to work from not only the center line of the fixture, but I have to get the part position exactly where I would have it in the CAD system in CAM for me to be able to move this thing around for the CAM system to know where it goes. And that's really where the fixture offsets are going to come into play, these dynamic fixture offsets. Now I don't have to program relative to a known center line. I can just lay the 0 on the part wherever I want, and the machine's going to calculate. This is another good example of where I would want to use dynamic fixture offset. So even just a simple single clamping, like a little teeter-totter trunnion, but I now want to work on 3 sides. And I want to have the ability of kind of flipping it around. Once I leverage, and you'll see this in the demo, once I leverage the dynamic fixture offset, now I can program just thinking about where the 0 is on the part. And then as I rotate around, I can potentially put this block anywhere within my travel space, and I don't have to reprogram the part. It's all relative to the part, and the tool is relative to the part orientation, not where it sits on the machine. So certainly tombstones or fixtures where I want to hit multiple sides, maybe single clampings where I want to be able to machine on multiple sides, all great use cases for dynamic fixture offsets. So how does it work, right? What is the control doing? What kind of magic is this thing doing? Well, step 1, we need to know, the control needs to know where the center of your rotary is. Once we know where the center of the rotary is, now we can do some math to start to calculate things. So if you take a look at our little video here, you're going to see I'm tracking the same corner on this block each time. And what I want you to pay attention to is the coordinate display on the left. Now notice that every time I bring this little probe back down to that corner, my coordinate system for specifically the Y and the Z field are 0. So that's what we're doing. We're tracking as you move this part, and on the rotary axis, what would I have to do to shift to maintain the same 0 on the part? And that's really it. So we take the known work coordinate value that's sitting in my G54 or 55, whatever one I'm using. I take the known center, and then as I rotate things around, it's just some basic math, right? At a 45, I take a look at, or any interim angle, I do a little math. And generally speaking, what you would see here is as the part gets higher, I'm going to be shifting the Z system up and the Y in the positive direction. And then if we were to roll over center line, then we'd start moving things down. And we could track this thing 360 degrees around in space. Excuse me, a little tickle on my throat. Now, what functions within the Sinumerik control would lend themselves to this kind of dynamic tracking capability? Well, you really have two. We have Cycle800, and Cycle800 would honestly be the most preferred method for doing this, and it's the one we're going to use right now, or what we also call swivel cycle. And here it's going to be just like you saw before, but what I want you to pay attention to it is this little Z move. I go up and I go down. So what's happening with Cycle800 is not only do we track the zero, but we align the coordinate system so our G17 plane is always aligned with the spindle. So this move I'm showing, this is a Z commanded move. Simple, go Z move up, Z down. And as we go to each of these points, you'll see we rotate the coordinate system so it stays normal to the spindle. Why do we do this? This allows all of our CAN cycles to be able to work natively in this new orientated plane, and we don't have to do any other additional special commands. Now, if we look at the behavior on the right, this is introducing tool center point control, what we would refer to as rotary. And in this case, as I start to move around, first you'll see the motion's a little different because we can track as we move between positions. But now look at the little Z move I made. Exact same effective program, but rotary or TCP keeps your coordinate system fixed on your initial coordinate system. So my Z is staying normal to that first face. And that's why you're going to see the Z direction. Now I start to get a 2-axis move, and then I get a single axis move, but now in the Y. So that's the Z the entire time. So why this makes this a little more challenging for a basic dynamic fixture offset is now I'll have to add in some extra commands to effectively rotate my coordinate system, make them normal to the tool, or I would not be able to use any CAN cycles. So I would say by far the most popular method, and what we're going to focus on today, is using Cycle800 or swivel cycle and allow that to track the zero. Okay, so how do we set it up? How do we use this function from a an operational standpoint? Well, there's one additional or new probing cycle that I would start to look at when I start to adopt dynamic fixture offsets or Cycle800, and that's what we call a line edge. So on a simple 3-axis machine, I really just have to come down, find the top of my part in Z, find my XY location, and I'm good to go, right? Maybe I could do a coordinate rotation if my vise wasn't square, but I don't need to square anything else up. The minute I mount the part to a rotary, now I potentially have to rotate that rotary to become surface normal to some plane, right? To become square to some plane that I want to work from. So we do that with our line edge function. Now there are two methods for doing this. We have the direct axis method, where I'd be working with an offset that's written right into my direct axis of my rotary. And on the left side, we see we have a value sitting in the A offset. Or I can use coordinate rotations. And then coordinate rotations, I don't have any offsets in my direct axes, specifically the A, but I put them in the coordinate rotation field. So why would I choose one or the other? A lot of it's going to be based on my programming method. So if my CAM system and the post was designed to work with coordinate rotations, or maybe I need to use coordinate rotations for other tricks, then I would want to make sure the setup uses coordinate rotations. If I was going to have everything be direct axis positions, even inside of my Cycle800 for programming, then I would use the rot axis field, and I would drive my offset into the direct axis. So let's take a look and go through a simple setup so you guys can get a chance to see how I would work with this type of scenario. So in this example, we have my little Fryer CM20 machine here. Same machine that you guys have probably seen in my studio before. I'm going to maybe get rid of our guard, get rid of the base so we can kind of really get in and see the machine. So in this case, I have a fixture that happened to be bolted up. So when I put the machine to a 0, it's not at 0, right? It's sitting at some angle. And there's always most likely going to be something. It's very difficult for me to start to bolt this stuff together and have to align it mechanically so it's not spun. And that's okay. But I do need to make sure that I align this surface, this top edge. Let's say I'm going to work from that top edge before I go and set my part 0. All right. So your order of operations is going to be doing your align edge first, and then your set 0 second. Now, what I'm going to see once I have a machine commissioned for swivel cycle is in jog, we're going to get a basic swivel command. So generally, I want to make sure that I can turn swivel on and I drive the machine. So if it was left sitting in some other area, I can drive it just to 0, 0, 0. And that's going to now give me a platform to do my align edge. So that's usually my first step. I like to make sure whatever work coordinate I'm using, in this case, I got a 516. I look at the work coordinate, probably don't want to have any values in here. So there's no direct axis values. If I go to details, there's no coordinate rotations, right? That's kind of step one. Drive the machine to a 0 location, preferably using the swivel cycle. And now we can come down and measure 2 points along this edge using our align edge cycle. So when it comes down to using that, it's going to set up very similar to probably what you're used to. I'm going to do a standard measuring on a G17 plane, going right to some given work offset. And then I choose what my measuring direction is. So a lot of times when I start, it might be set up to measure an X or Y. Well, if you think about this scenario, I'd have to actually move the probe in a Z direction for my measurement because I'm calculating this angle. So pick Z, and then you got to tell it what is my reference axis. So if I look at the machine, am I moving in the X for my second measuring pick, or am I moving in the Y? So if I think about the slope, I would be moving in the Y. So that's your reference axis. And then I decide what is my 2 methods, which do I want to use. So I'm going to use a basic coordinate rotation. And there's no need for a special angle at this stage. Now bring the machine down, get us ready to probe. So I'm just going to jog her in close. The beauty of having collision off, we can shut the collision detection off. Don't do this on your real machine. All right, just to get me quick. Your order of measurements here, if you can, follow the direction. In this case, with the Y here, it's kind of telling me take my first measurement in my Y plus, second and negative. I find with the align edge, I don't generally see a different result than desired, but not a bad idea to always kind of track the little GIF here. So I took my first measurement and highlighted P1. I move back, maybe take my next measurement, cycle start. She comes down, trips the next surface, and then just simply say set work coordinate. And what this is going to do now, it's going to calculate whatever that shift is. I can drive it to that position. Right now I'm not going to because I'm going to use the swivel cycle to do it. But I see I got almost a 10-degree deviation. If I look at the work coordinate, and I'm going to go into the details of the work coordinate, right? I see I do get this little symbol, nothing in A. Go to details, and now you see I got a coordinate rotation about X of just about 10 degrees. And this is going to be what aligns the part. If I send it right back to 0, 0, 0 with swivel, and I'll let it go retrack. Now we should be straight on the table. That just adjusted my 0 location. Now I'm ready to come down and do the rest of my measurements, which would be finding a 0. So I'll set a quick 0 for our next example. because I am going to write a little program for you working from the center of the part. So I might as well set it right now. So I'm just going to kind of eyeball her roughly in the middle. This will be good. Close enough. And then I would do what I would normally do, right? Probably find the top of my part in Z. I'm just going to set the top to be 0. I'm not going to face it off or anything. Then I'm going to find the center of my part with our 4-sided boss cycle or spigot cycle. Let's roll around the rectangle. And now I have a 0 set in the middle of the part, top of the part, and it's adjusted. So if we look at the final offset stack, you see our 3 linear shifts, X, Y, and Z, and our angular shift inside of my coordinate rotation. Okay. And as I go through, if you guys think of questions, throw them in the questions tab. In the end, we are going to spend some time going through your Q&A. All right, so now that we've gone through the basics of aligning for this whole tracking, now we want to take a look at what a part program would look like. And, I always see a lot of value when I'm first getting my head around, commands like this would be just to hand write a real simple G-code program that will start to show us what are some of the cycles and functions I would use to support this. So in our case, we're going to do a basic 3-sided part path, single tool. We're going to make 3 pockets on 3 faces of the part. I'm going to show you kind of how to step through that beginning to end, and we'll be able to simulate it and run it. Step 1, obviously, let's create a part program. So I'm going to jump over to my part programs area. Now in this machine, I happen to be working from my extended NC memory. I have a nice little folder here, which we have some examples in. So I'm going to create a brand new program. It's going to be a G-code program. Yes, you can do everything we're doing here with Shopmill for sure. In my mind, probably a lot more of us are using CAM-based programming. So I figure, let's show it in G-code, and we're actually going to show a CAM solution program as well, so you can really see how the CAM system's putting it out. But I'll just call this demo 1 and start my program. So my normal programs would always start with some kind of a safety line. This is no different. So maybe I want to make sure I'm in absolute mode. Maybe I'm in G17 plane mode. What is my unit of measure? I'm going to be an inch in this case. Certainly it could be a metric. What is my work coordinate, right? So I'm using G516. That's pretty common for a standard safety line. Now in this case, the next thing I would want to do, because I'm working now with a rotary, is how do I know the operator left my table square at a 0 location? I have no idea. So I want to tell the machine to go there. And this is where we're going to use the swivel cycle for our first opportunity. So if you go to the various horizontal soft key right next to simulation, and you go to our vertical soft key called swivel plane, this is that cycle 800. And you'll see as we save it, it'll save as cycle 800. Now within it, you can define what plane you're working from. Generally, it's going to be G17. I don't need to because I have the G17 in my safety line. But if not, I can certainly put it. It's not going to hurt me either way. Now, usually what you're going to see on your machines is only one kinematic type. In this case, for this demo machine, I have 2, and we're going to explore why that is a little later when I show you the back-end setup functionality. But for now, it doesn't matter which we choose. I'll just use the classic. But this activates the dynamic fixture offset functions. This activates what we call our tool carrier. The retract method, this is going to give me an opportunity to get the head up out of the way before the rotary swings. And what ones you have here, that's really dependent on the OEM when you commission the machine. Generally speaking, I would always expect to at least have the Z retract, and this is going to go usually to the extent of the travel in Z. The ZXY will move straight up in Z first. That's where there's a space between the Z and the XY, and then move the XY simultaneously to a safe position before anything spins. Then you can do like a little retract one. This is good if you use the tracking function. but we're going to use a full retract. From there, I want to have my swivel as yes. This is telling the system that I want you to actually move the rotaries. If you say this is no, you can use this page as a calculation, but it won't actually spin the rotaries. So we would want this at yes. You can do new or additive. Now, the first one should always be new, but if you're starting to stack rotations upon rotations, like, hey, I want you to move 45, then move an additional 10. If I do additive, it keeps the previous 45 and just adds the 10 to it, giving me 55. If I do new, no matter where my rotaries were orientated, it always goes back to my G54, or in this case, my G516, right? My base work 0. So a 45 followed by a 10 would actually move the machine to 10 if I'm at new. Additive would move it to 55. So think of it like absolute and incremental programming. New is more like your absolute. This allows me to shift the 0 around. I'm not going to do that yet. Here's where I can pick my different strategies. And in this case, do I want to do what we would consider a kinematic independent programming method? That's axis by axis, where I then tell it to rotate about a linear axis. Or do I want to do direct, which now would require a machine that has an A-axis? So usually why I would choose one or the other. One, if maybe I have a part program and I'm going to move it from a machine that has an A rotary to one that has a B rotary. If I use this, the program would work on either two machines. Or the other option would be, how is my CAM system generating it? And the third could be how the OEM set up the machine. So it's up to their control whether they want to give you the direct axis option. Axis by axis is always there. Direct is actually turned on through the parameters. Then you do have your order of operations. Now, in a simple single rotary machine, there's usually not a lot of benefits to this because you're generally always going to plug the value in the X field. You may introduce a Z if you wanted to spin the coordinate system, but that would always have to happen after the X component. So you're really only going to use effectively these first two, what I say would be the most logical to choose. So I typically leave it at an X, Y, Z. And then I'm going to tell everything to go to 0. So I just want to make sure the table rotates to 0, no more shifts, and I don't need to worry about this little selector. From there, now my table is square. Certainly I could insert my blank if I wanted to have some graphics for simulation. You could cancel Cycle800 now. You'll see that done a lot. But in my case, I want it on the whole time when I'm machining, so I'm going to leave it alone. So now I'm just going to toss in a quick tool change. I'll grab maybe a 3/8 NML will be fine. We'll do our M6. We'll do our D1 for our offset. Maybe turn my spindle on, give it a little rotation. Maybe I want to now position, and I'm not going to tell it anything about the A axis, right? I'm going to leave the swivel cycle to managing the motion of the A. I do not want to see any rotary motions here because it's all handled in swivel. So I'm going to just maybe send the machine to, somewhere close to the part. Then we go in and we do a little can cycle. So I'm going to mill, do a basic pocket mill. Now here, time's sake, I've already filled out some basic parameters. So I'm going to have my 0 to be dead center of the part where I set it for the pocket. Top is 0. We'll do a 3-inch by 1-inch pocket, a little 1/4-inch radius, 1/4-inch deep. We'll take it all in one cut, 60% step over. I'm just going to let this plunge straight in to machine it. So what that would do is that would now give me a basic program machining a pocket, right? There she goes around on the top of the part. Now let's say I want to shift my 0 to this top surface and I want to machine the same exact pocket, but on that surface. So now this is where I'm going to kind of bring in the swivel cycle again to kind of manage all this. So since I don't have any tool changes, I'm going to use the same tool, keeping it simple. I go to my various, I go to my swivel plane, and now I can introduce this coordinate shift. So generally what I like to do is I like to shift my coordinate system up to the point that I'm rotating about. So if you think about it, I'm going to rotate about this corner. So if this block is 2 inches by 2 inches and 4 inches long. So if I shifted my Y positive 1 inch up, that's going to put my 0, because it's shifting my 0 to this top corner. Now, in my case, I would do a rotation. If you have a handy little coordinate cube like I have in my hand right now, I look at the rotation around X. I would be going in a negative direction, 90 degrees. And that's going to say, hey, rotate the coordinate system around this top edge 90 degrees. So at this point, my 0 is going to be sitting right there. My Y is actually facing down. And then if I want to slide my 0 any further down, I can now say, hey, I want to move my 0 a little bit further because I want this pocket to be dead center of that face. Now at this point, I can quickly paste in that pocket because dimensionally it's working from the new 0 and the same 0 location I was, which is in the center of this surface. So if I run it now, we'll just let it machine the first one. It goes pretty quick. I'm going to slow down. There's your rotation. We'll zoom around. There's your next pocket. Driving from the 0 that's now in the center of that face. Now, if I want to do this back side, now I'm going to get my 0 in position on the back and call it the same pocket. And this is where we can kind of discuss that newer additive, right? So if I'm on pocket, I go back to various and I go back to swivel plane. If I'm a new, all I have to do is imagine the part's already rotated back to its original state. And really all I need to do then would be take this and say, I want to go backwards, -1. I want to do a positive 90, not a negative 90. And I want to shift down -1. And these would be the values from this initial 0. Had I wanted to do an additive, then I would have to back everything out, right? So I would probably have to stack this in 2, or I can shift my 0 down and flip it 180. It gets a little confusing if you think about it, because it would be rotating in relation to this last move, which is really a 180-degree rotation. So generally, I typically stay in new unless the position I can only achieve by stacking it on a previous one. Now you're probably asking yourself, what's this little plus or minus do? This is only utilized when there's 2 solutions to the resulting rotation. But if I have a single axis, there's only ever 1 solution. You only get that when you have 2 rotaries. So this isn't going to really give you any benefit. I would just leave it at its default right here. So we accept it. We grab some toolpath. We now simulate. We'll get our first toolpath. I'll speed her up a little bit. Let me zoom over the back one. And then the end, we're going to flip to that surface. I'm going to machine that surface. Now, probably in the very end of the part, I'm not going to want to leave it sitting like that for the operator to load the next part. He would probably be cursing me. I certainly wouldn't be happy if I was him. So in the end, now I can kind of do my kind of safe shut-off routine. So probably want to maybe kill my spindle, kill my coolant had I been using it. But you can use swivel now to send the machine to a safe retract location. And in this case, see this basic values? This is a great way to just kind of delete all this stuff down in here, right? You have basic values. It sets everything back up to basic 0. I would want to make sure I'm maintaining my retract, because basic values doesn't change the retract strategy. So I do want to do a retract, make sure everything else looks good. And now when I accept, this last move is going to send the head to a safe retract, put the table there. And then if I wanted to maybe center the table, this is where I might introduce like a SUPA command for those of us that are familiar with SUPA. And maybe I say, hey, I'll center my table and bring my Y close to the front. And that would be a kind of a traditional shutdown. So if I look at my complete part, now you see we do our first surface, shift to the next surface, final. There's your retract. And now I have a nice loading position. If I look at my machine, kind of centered, my operator can load up my next job. So certainly simple, intended to be so, because the next we're going to get into the cam. But to just kind of emphasize why would we do this, or what's the big benefit. Now let's say, for argument's sake, this block was in a new location. Well, now I can come in the exact same program, and I can just shift my part around a little bit, and my 0 location will track with this new position. So let's say, for argument's sake, I went into my block, and I'm just going to put it over a little bit, up a little bit. So maybe I had some new jaws, new work holding. Let's assume that I could hold the part in this position, right? So now, if we come out and re-zero it, I'm just going to come and jog real fast. We'll go grab a probe. No matter where my part is in space in relation to the rotaries, the system will track that 0 appropriately, pick up or pick down. So I'm working from the same part. So I could say Y go to maybe 0. I have to move it up a little bit. X go to 0. Z probably want to come up a little higher because I know I shifted it up. We'll do a quick rapid there. Okay, so just kind of getting me close. Now I'm going to jogger into the new location. All right, roughly the new 0. Oops, we're a little low. And now I'll just do a quick measure, Z. And we'll do our final measure. Okay, so now with a new 0 set and my block in a completely new random location, I can still go straight back to my part program, cycle start, and this would never work had I not been using dynamic fixture offsets with Cycle800. There you go. That is why we do it right there. It gives me total freedom, lets the machine manage the center line of the part. I don't have to try to position things exactly where they were in my CAM system, right? I have complete control over where this is right on the shop floor. Okay, so certainly we gave you a simple example. Let's take a look and see what a CAM-based program would look like. So in this case, we're going to take a look at a program that I posted. I happen to use Mastercam for this solution. Really doesn't matter which CAM system you're using. You should be able to drive Cycle800 in this kind of strategy. So I wanted to kind of show you and allow you to kind of see what I would expect from this type of toolpath. So in this case, I have the program pre-created under our little example 4. And here, you're going to see kind of an intermix. They're doing some SUPA commands. They are doing some A moves. That's okay, but you're going to see some undesirable movement. And then you'll see when I get to rotations, we are using the Cycle800. Now they're outputting an axis by axis strategy. So I would want to make sure that I did the coordinate rotation setup like I showed you. When we get to our first rotation, there's our 90-degree, similar to what you saw. You'll also see that they're plugging in some numbers and shifts. Now the CAM systems won't always do that. They may leave the 0 at where it was in the origin. I like to shift the 0 because this way, as an operator, I can kind of tell a look on depths and whatnot. So we'll explore that as we get a little further into it here. In this case, this is going to be a back surface. Now there's my 270 switch with a 180. So for whatever reason, they wanted to spin the coordinate system around, probably the way I created the plane when I did it in CAM. I do a little chamfering. So we do some 45s. So really, it's effectively use Cycle800 to set up your plane and then attach some toolpath to it, right? So in this case, a lot of G0s, G1s. So let's take a look and see what this would look like running, and then we can kind of dissect it a little bit. I am going to reset our workpiece initially, and we'll run it. So you see that first little funky looking jog move there? Let's take a look at that again. So I'm going to slow down the machine. So see that little blurb and back? So that is them positioning the A directly. Now keep in mind, I don't have an offset in A. So this 10 degrees that I adjusted out is a coordinate rotation. So if cycle 800 is not driving the machine, it's going to go back to that A position. So that's not a great scenario. Now, in the beginning, does it really matter? No. But when we get to the end, you're going to see it's going to leave the machine at an angle. So that might be something I would want to kind of tweak in my toolpath. There we have our first pocket on that back side, a little dynamic milling to machine that little pocket. And then we're going to wrap it up. I see some CAM systems will use our retract strategy in Cycle 800. Some will still do it with a SUPA on their own. It's not bad either way. Really up to the post developer if he's got his head around it. There's a little chamfer action. There's a little chamfer on the back side. All right, so there's our part. And now if you look at the table, give you maybe the machine so you have a little better reference. See how she's sitting at a weird location. So in this case, this is all a behavior of the very end of the program where they're using a SUPA command. So there's a couple ways I could now address this. I could plug in another swivel cycle, get rid of this A, and allow that to straighten up my part. Now I do already have the retracts and stuff in place, so I don't necessarily need to do that. In this post, what we did was we incorporated local variables right here to set up these safe retract positions. So if I know, and I only know because I measured it, that I would need to adjust this platter 10 degrees to make it straight, or approximately, I could plug in a 10 here, and now at least any SUPA that's used through the program would now move it to the right location. So that would be maybe another way. See, now you see I don't get that little bobble. It went right to the 0. And then in the end, when we get there, you'll notice everything will be square. So you'll kind of play around with this a little bit. Now I'm going to feed hold it once we get into the pocket, because I want to show you why I like to have it shift the coordinates in Cycle 800. All right, so we'll do our next pocket. So the side pockets, I made them an 1/8 of an inch deep, 125 deep. So now let me get it all the way down. We'll start machining. So now if you look, I'm going to get rid of my frame so we can kind of see in here. Good. All right, so the tool is fully engaged. It's about to start machining this pocket depth. And when I stop, you see how my Z is telling me, oh, I'm an 1/8 inch deep from this surface. That's only going to display this way because if we look at the cycle, that's going to be the op 3. It shifted the coordinate system back. So now my depths are relative to these planes. Had I not had this shift in place, then as the operator, I'd have to think, okay, what's the thickness of this block? Okay, well, I know it's 1 inch. And then what is the depth of my pocket? Okay, minus 1/8 of an inch. So I should expect to see 875 here, plus or minus, right? So you have to think a little bit more. So I personally like to be able to see my features from probably where they were dimensioned from. But that's all a behavior of this. If your CAM system's not doing it, it's okay. Just keep in mind that when I look at the display, it's going to be a little bit harder to read, right? Okay, so there's the pocket, and at the end, we did shove in that little offset there. Now there's another move that it was a little interesting, right? Did you see how it swung the platter over top? In that case, maybe I don't want to do that. Maybe my part's sticking out far enough that it could hit the table. That could be bad, right? So the way this machine is initially set up or commissioned, The rotary axis is what we would refer to as a medulla axis. So if I was to jog this rotary, slow it down a little bit. I'll speed up a little more than that. So see how it just spins indefinitely? Now in this case, my part stack, it wouldn't hit the table. I'd be fine. But I could have an issue there. And I'm probably not going to want to start recommissioning this machine, so this overlap of this medullo functionality can't occur anymore. So how do I fix this thing from flipping over when it goes from the first side to the second side? Well, what happens is a lot of people, as they get used to these cycles, they think, oh, well, that's an easy one. The rotation just before operation 4 should be that one. This is where it flips over. No, probably this one. This is where it flips over to the 270. Well, could we use this plus or minus? This will have no effect on it. Again, there's only one solution. What ends up happening, though, is the system always tries to move shortest path. But when you get on that 180 degree, it doesn't really know which direction, so it's making a choice. So if I have a scenario like this where I got to ensure that I'm controlling the direction from one rotation to the other, here I would probably stack one additional swivel plane going to 0 and effectively breaking this up into two 90-degree moves. So let's say, for argument's sake, now I do a quick start search from our first plane. I'm going to do a mid-program restart. All right, yep, go. So now it's coming down. Machining, we'll speed her up. Cranking around, I'll slow it down just before we do it. So here, just about there. Let's slow her down. So now you see 1, 2. Now I have full control, and I would potentially not cause a collision issue by rolling over top. So you do have to kind of play with that a little bit. If you are putting it in a scenario where it's got to do a 180-degree move, you may not have full control over which choice it's going to make. But then to finish it up, we'll do our 2 little chamfers. And then since I pushed the offset of my tilt into my little local variable there, I didn't do anything zeroing out the axis or anything, but it allows me to position it 0. Or for sure, I could have the post outputting a base cycle 800 here. It's kind of 6 of 1. But hopefully this kind of gives you guys a little bit more visibility in what I would expecting my cam output to look like in starting to use Cycle 800. Okay. So now, kind of the last thing I wanted to take a look at, really before we open it up to questions, is how does this all work in the back end? You know, if I have issues, where am I going to be looking for the data that's holding the center line? So there's really 2 different commissioning strategies that OEMs are utilizing today. They have what we call our classic transformation. That's what you see on the left, where the swivel cycle setup page holds the direct numbers for the center of rotations. The downfall with this is, as we have different other types of what we refer to as transformations. So swivel is a type of transformation. Traore or TCP is a type of transformation. For those of you that may have heard of the term trasil or transmit, right? That's cylinder surface transformation. They're all different types of transformation. Historically, we'd end up with the same numbers in different areas. So it makes it confusing when you're going to calibrate things and check things, because you start to have numbers spread through all kinds of different pages and MDs. So it's been quite some time where we've adopted what we call a kinematic chain, or a chain-based transformation. That's what you see on the right. And a chain-based transformation, now inside of the chain components, you have offsets, and that holds that value. But now multiple transformations can all work on the same chain. So to show you a little bit of what that would look like on my machine, if you go over to your setup area, and we go over to NC, you have model and transformation. So let's start with this transformation button. I would need to be at least at the service level, if not the manufacturer level, to get into some of this stuff. But you go to transformations, And now in this case, you see these two. So you would have just one or the other. So again, if I open up the classic, these two numbers are my critical numbers. This defines the center line in Y, and that defines the center line in Z. And then usually what you would see then, we would close what they call closing the vector. So I would use the inverse, right? That's a negative. This is a positive, same exact number. This is a negative, that's a positive, same exact number to take the vector, we refer to as a vector, and then look it back on it to itself. So that's pretty standard. But if I found that I had a discrepancy in my center line, these two numbers would be my two culprits. And then whatever I change them to here, negative, I just got to put the inverse down here. The X component means nothing, because if you think of the X is the center line of the A, which is infinite, right? I have an infinitely long center line. It doesn't stop anywhere. The X could be significant had I maybe had a secondary rotary, but I don't on this scenario. So you could leave this X at 0. I could put 1,000,000 here. It doesn't matter. But if I do have a number here, it's not a bad habit to at least close itself. But this is what sets up the transformation. Down here is what sets up some of the other options and functions. This is where the retract values are set by the OEM as to where I want to go when I do like that Z retract only. So this is what we refer to as a classic. Now, if you're on significantly older software, we didn't have this transformation button on the previous page. Back here in the standard setup screen, if you expanded over, we had a swivel data page here. That was the original scenario. But we've had this NC transformation area for quite a long time, probably 7, 8 years, maybe longer, maybe at least 7 or 8 years. I think version 4.8 was where we introduced this style of commissioning. Now, when you get to the chain, when you look at the transformation, it has a couple components it's calling out, but no real numbers here, right? No real numbers to find the center line, because you now have a machine model. You have what's called a kinematic chain. Think of this kind of like an assembly of all the components. So in this case, hey, I have a y-axis. I have a y-axis that carries an x-axis that eventually carries an a-axis. And then what we do is we plug in these correctional offsets. So as you look at it, you can have a correctional offset or a standard offset. And the standard offset would be where I would see those two values. The correctional offset comes in when I want to then measure and adjust it. So I can leave, think of the first offset as like the dimensional data of the machine as it was designed by the designer in CAD. But when I build it, it's never going to be exact, right? So I could use the base value of, say, hey, CAD thinks this is going to be 17 inches down and 6 inches over. In the real world, there, it's maybe another, 30 thou, 40 thou over. You would write that into the correction offset. So those would be the two different scenarios that you would start to see from a configuration standpoint on your machine. Now for us, chance to plug our next event, I will be doing a YouTube live digging into the calibration side of this, and there we'll talk about the chain as well as the classic version quite a bit. We're going to dig into a function we call Cycle800 or kinematic adjustment, where I can put a tooling ball on the machine, come down with a probe it, and it'll calculate and find that center line for me. And the center line is critical, right? This is only going to be as good as where that center line of the part. So rotary's got to be square, it's got to be straight as best I can, but I also have to know that center line, and that's important. So if you have time, come and check it out. It's on the Mr. CNC channel, so you can go there. You can give yourself a little reminder. It's going to be on the 30th of this month. So building on the event that I showed you, now we're going to get into how to calibrate it and measure it. Okay, so with that said, I think it is time for our Q&A, and there's my contact information for you too if you want to get a chance to grab it. Oh, so Dan, did you have a chance to kind of browse through any of these questions? I do have Dan on the line. He was hopefully helping some out.
Now we have something in the question queue. We'll start from the bottom. What is the main feature of cycle using Cycle 800? What is the difference between other cycles and functionality? So I think you kind of touched base on this one in your first couple of slides, where one of them where you were showing the animation between Cycle 800 and the difference between uh, the Cycle 800s and how it tracks that zero. I think is really key.
To Traore. Yeah, absolutely. I would say Cycle 800 and Traore are very, very similar. Cycle 800 during the rotary motion is not dynamic, it's static, right? So that's where I have to send the machine to a safe retract, drive it to position, and then come back. Traore is a true dynamic transformation where it'll rotate with it, right? When you saw that original slide, I could probably go back to it early on. Let me find it here. Oop, not this one, not that one, not that one. Come on. This is not the fastest of. No, I want to go to the Traore one. Next one. Yeah, so here you see the Cycle 800. Kind of let me get out of the way as opposed to the dynamic move. But the big trick there is Cycle 800 will automatically align your tool plane or your G17 so I can use all my can cycles, drilling, pocketing. Traore, I would have to add rot commands, translational commands to be able to kind of shift things around. So it's a little more complicated. The other thing with Traore is it's an expensive option because it's really designed for 5-axis. So you tend to not see that type of option on a basic 4-axis machine like this, right?
Yeah, and then we got
Yep.
another one here. Can you move the cutter from Y minus to Y plus or Y plus to Y minus while the milling up profile cam track around a tubular part? Yeah, I think this is no problem. And this is just depending on where you're at with your work offset. You can have it in the center. This one might be in the center of your part. Did you?
No, I'm reading it. I'm trying to get my head around exactly what he's trying to do. A profiled cam track. So if he's trying to profile, though, with a continual A motion, you're not using Cycle 800 for that.
Yeah.
Cycle 800 designed, originally we call it 3+2. In this case, this would be 3+1, right? Where I'm going to stage the coordinate system, hold them there, and do my tool path. If you wanted to kind of wrap and get a angular and linear motion, you're probably looking at trace-cell, and that's a different topic entirely. We can delve on that another time. But keep that in the back of your head. Swivel cycle, Cycle 800, you move the rotary, you hold it stationary, and then you move your linears. You're not doing any continual machining with the rotary and the linears moving. You need to do something like that. You're going to use TCP with Traore. You're going to use trace-cell. That's a different type of beast.
We got one here. Just trying to find out, some more information. They got a machine with a Sinumerik One and digital twin.
Yep,
Here's some
yep.
good resources. I think you kind of touched base on this in the beginning of your webinar, where you kind of talked about kind of our online training, our in-person training. We have a lot of good resources in the beginning of the webinar, and I would circle back to anyone that wants to know information on our YouTube or any of the links that are shown here today. But certainly visit Mr. CNC or Mr. CNC Insights to get more information or join our contact list.
Perfect. What else we got?
So what are the special features of Cycle 800? What type of configuration can we find in it? Is there a license fee?
Good question. Good question. So Cycle 800 does not require a license. So it is what we would consider a commissioned option by the OEM. So OEMs may charge to set it up, but really because there's obviously tasks on their end in configuring all the machine parameters, doing all the alignments on the machine. But from our side, no license required. So it's certainly something that even if you got a machine and maybe you added a rotary later, or you had a rotary and you said, hey, I'd really like to use this feature. Can it be turned on after the fact? Absolutely can be turned on. We'll work on any of our controls, 828s, 840s, Sinumerik ones. But what I would say is if you want to add it to an existing machine, reach out to your OEM. There are a fair amount of steps to commission it. So you could find yourself in the weeds pretty quickly. But I would not think it would be a big lift for an OEM to add it to your machine.
And then programming from the control. So we had a question here. It says, is it programming from the control? I think you touched base on this in the webinar. You can do it from the control. You also can do it through CAM. So you have a couple choices there. One of the things, I don't know if you touched base on it, but you definitely did it in the webinar. But from your CAM system, Cycle800 is posting out the same mask that you would see on the control as you would see in a posted program. So it would.
Yeah, good point. So specifically from a shop mill perspective, right? Yeah. So if I was to like look at a shop mill program, and right, I'm in the shop mill environment, go to various, guess what we get? Same exact button I had in G-code. Now the cycle might look slightly different because in shop mill we let you do tool changes in cycles. Other than that, everything I showed you directly applies. Same thing. Cool. What else?
We got one more. Is like, how do you activate direct mode for Cycle800 if there's not currently available?
Somebody wants to directly. Okay. So it is part of the mask setup. So you do have to first know, does your machine use the classic method or the chain method? And based on your version of software, do I have this transformations button, or do I need to go to the old swivel data mask? Okay. But outside of that, either of these two in the bottom here, this is where we control here. There's our retract position, swivel modes, axis by axis. So here you go. So in this case, axis by axis is always a yes. And that was why I was telling you in the event. Generally, I'll always use axis by axis, not only for the benefits of it, but I always know it's going to be there. The other three we have, I didn't even show you some of these. We have projected angles, solid angles, or rotary axis direct. And in this case, if my rotary axis direct is at a no, then I won't have it anymore. So if I was to go back out to, just go jog real quick. I probably need to reboot too. Get it to show it, I bet. Some of these you do have to reboot on, some of you don't. But what would happen is, yeah, the directly would go away or come back. But that's how you do it. You need to go into the transformation. You need to find the option, and you need to make sure it's at a yes for rotary axis directly or direct. All right. Anything else, Dan?
That is all I see.
All right. I'm trying to see if there's anything else. I think we're probably in good shape. What I would say is, certainly, if you guys have a chance, please join us for the next event. Again, coming back in the end of October. Here, we'll get a chance to kind of explore more of that setup stuff. Alignment, maybe how do I check to see if my machine's moving around even before I try to align it. So there should be some good content there. But with that being said, Dan, thank you for joining and kind of keeping an eye on the Q&A panel and working with me here. I always appreciate it. Everybody that came out for the event, thanks for joining. Hopefully you enjoyed it and you got some good information, and keep coming back for more. We like producing them, so we hope you guys enjoy watching them. And with that being said, thank you from the Siemens team and Mr. CNC, and we will see you guys soon. All right, have a great day. Bye-bye.